This last one's a little bit different. We're going between the same parabola, but now the line y equals x. So we have a different region we're dealing with. And the cross sections here are semicircles. So I'm going to draw a little line parallel to the y-axis again. And then from there up, I'm going to draw a little semicircle with little thickness to it. Now the difference between this one and the last one, the quarter circle, that distance between the two graphs was our radius, but here, that's our diameter, right, since that's a semicircle. We need to keep that in mind when we're setting up the area, because area of a semicircle is just going to be 1/2 pi r squared. We need the r, but first we have to figure out the diameter. So diameter is going to be the top function, which we already know is square root of x, minus the bottom function, which is x. So the diameter is going to be square root of x minus x. What's our radius going to be? Half of that, right? 1/2 square root of x minus x. So our area in terms of x is going to be 1/2 pi times 1/2 square root of x minus x, that whole thing squared. So just for time's sake, we can set this up 1/2 pi times 1/2 square root of x minus x, that whole thing squared, dx. You could simplify that if you wanted to, but if you left it that way, that's fine. The only thing is we need to figure out a and b. So we need to figure out where these two intersect. We want to know when these are equal. So we want to know when square root of x equals x. We can square both sides, get everything on one side, and then factor. So we get 0 and 1 for our upper and lower limits.